Testing, testing, 1, 2, 3. 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 Good. All right. Thank you. Perfect. All right. So once you mic'd up, of course you can't leave the room because if you do, it'll just throw it off and we'll have to resync it.
Not a problem.
Let's put it about right here.
Okay, thank you.
All right. Can you say something for me?
Pardon?
Can you say something for me?
Hello, how you doing?
One more time.
Hello, welcome to Virginia Tech. Thank you. I'm ready. Ready as I'll ever be.
Ready as you ever be. It should be on.
Yeah. Yep. Hi, Malika.
Hi. Do you brief with wine?
Pardon?
Do you brief with wine?
I can. I have. Wouldn't be the first time. All righty. Well, welcome everyone. Welcome to, and for those of you who are Hokies, and a number of you are, welcome back to Virginia Tech, at least some part of it. My name is Tom Wotecki, and I'm the director of the degree program up here in Data Analysis and Applied Statistics. Very happy to have you here. What I'm going to do is give you a tour of the degree, and I'd be happy to answer questions along the way or at the end of the briefing or out in back in the room. We'll be here for a little while beyond the actual presentation so you can enjoy the refreshments a little bit. Several of you have asked how I got here, who am I, that sort of thing, not unexpectedly. So let me give you a brief introduction of myself, and then we'll talk about the degree. I am a Hokie, 3 degrees from Virginia Tech, master's in bachelor's degree in mathematics and a PhD in statistics. I have spent the vast majority of my career actually in industry. I did start out as a junior faculty member at a couple of universities, but my career took a turn, and I spent certainly 25 or 30 years of my career in industry or in the private sector anyway. I've been a technology officer, a chief information officer, a chief data scientist. I have led very large-scale enterprise software application development. I've worked in the pharmaceutical industry. I've worked for Cisco Systems, led a global consulting practice, and so on. So a great deal of experience in the private sector and industry, gaining experience not so much practicing as a statistician, but understanding the role of data and data analysis and statistics in various business enterprises. The pharmaceutical industry being an example, and I know there's an individual here who's working for Amgen. We were talking about that a little bit, the importance of data analysis and collection and understanding how to design an experiment in a pharmaceutical trial. I'm on the board of advisors to the Dean of the College of Science, Dr. Sally Morton, and in that capacity got involved in, I was requested to provide some advice about the prospect of offering a degree up here in the National Capital Region in data analysis and applied statistics. And that conversation eventually turned into a discussion about, would you like to lead the program for us? And that was a really, really exciting opportunity for me. It was a great time in my career to consider that opportunity, and I was more than delighted to take advantage of that opportunity, get back with my alma mater, lead the development of a new program, and help the university, in particular the College of Science, enlarge its footprint here in the National Capital Region, which is a very critical element of the university strategy, enlarging its presence here in the National Capital Region for a variety of reasons, not the least of which is all of the technology work that happens up here in this area. And the university's leadership in science and technology, and therefore wanting to be up here. So I am now the director of the Data Analysis and Applied Statistics Master of Arts degree here in the National Capital Region. We do have a very nice website. It's got a very complicated URL here. How do you get there? You go to the statistics department, you look for the link that says academics, and you find your way to the program up here. So in case you don't have a copy of the URL, you can find it by that simple method. And here is a little look at the website. There's a lot of information out there about the program, how to apply, what's the program about, why is it data analysis and applied statistics, and so on and so forth. And there is also some information about our wonderful faculty that are adjunct faculty, and I'll talk a little bit about those. I've had the opportunity to introduce Laura Freeman to several of you. Laura is a PhD graduate of Virginia Tech in statistics. She's a member of the Hume Center here, which is a research center focused on security issues, but she's also a faculty member in the Department of Statistics. She's going to be teaching one of the courses here. And I'll talk a little bit more about faculty. There's some other staff members here I'd really like to introduce. Wade Stokes in the back is part of the development team, along with Katie LaFawn. Thank you both for setting this up. Over here in the corner is Sherry Nelson, who is my executive assistant. If you, and I hope you will, consider applying for the program, you're going to be dealing with Sherry. She knows the ins and outs of how to get you enrolled and so on and so forth. She's a big help to me. She will be a very big help to you as well. And so if you hear from Sherry or Sherry to take care of that, you'll know why, because she can solve the problem that I don't know how to solve. It's as simple as that. So let's talk about the degree, which is what you all came here for. It's a Master of Arts degree in Data Analysis and Applied Statistics. It's similar to a degree offered in Blacksburg. The same degree is offered in Blacksburg. We got state approval to offer it here in the National Capital Region. So it's a fully qualified degree to be offered here in state approved, offered here in the National Capital Region. How is it similar? Or how is it different, if you will? At the Blacksburg campus, this particular degree is targeted to PhD candidates in another area other than statistics. So that gives you the student profile of the degree on campus. Here, the degree, as it's stated here, is targeted to a mid or early career professional who wants to get an advanced degree either for career advancement or for professional development. So we have a different student profile that we're aiming at. Also, the degree on the Blacksburg campus, and I'll get into more detail about this, allows a PhD candidate in another field, let's just use one as an example, perhaps it's economics or sociology, who wants to supplement their PhD degree with a master's in statistics because being able to carry out experimental design and statistical analysis is a real supplement to their education in that other field. Here, the degree will have different options that are available that allows you to match the degree program to your career aspirations. So that is very similar, but the twist is a little bit different. Again, early to mid-career working professional who's trying to get a master's degree to advance their career and choosing among the various options that we will eventually have available, tailoring the degree to their career aspirations. It's a 2-year program, 2 courses per semester, and why is that? Because it is targeted to a working professional. So that person would be taking courses typically at night. That is the intention here because we're trying to service working professionals. The courses are going to be taught by a mixture of adjunct and resident faculty. Laura is an example of resident faculty. She is here resident in the building. She's a full-time faculty member involved in a variety of activities. And adjunct faculty refers to someone who is qualified, such as a PhD recipient, who will then teach one of the courses. They are, in fact, a full-time working professional, but they will be the instructors in various courses. One of the other instructors this fall, besides Laura, is a PhD again from Virginia Tech in statistics. She's going to be teaching one of the courses that I'll describe here. Her name is Ana Maria Ortega Villa. She is a PhD statistician working at the National Institutes of Health. So there's an example of an adjunct faculty member, full-time professional, practicing as a statistician, has a PhD degree, will now teach a course for us, and she's very excited about doing it, just as Laura is, which I'm pleased to say. So we're accepting applications for admission this fall. We're going to kick off our first cohort this fall. But you can enter the program in any given semester. So you don't have to think about it as entering the program in fall. You can enter in spring, you can enter in summer, and so on. And each group of students that enters at a given semester we'll call a cohort, and they will go through the program together. And as the program grows, we'll have a large group of students who will have entered the program at various times, which means the courses that I'll talk about, all of them will eventually be offered at any given time. And so as the program grows, students will have a lot of different options about what courses they take, when they take them, and so on. However, for the moment, we're only at the starting point. The first cohort will be admitted this fall. A couple of people in the audience are actually applicants today with their intention of entering the program. Michael McNamee is an example of that. He's another Hokie. He's an engineering major with a minor in mathematics. I've talked with Michael on several occasions over the phone. I'm really excited about him entering the program, and I hope he does. So you can enter at any given semester. One of those semesters is, in fact, the summer semester. So let's look at the degree, the actual program of the option that we are able to offer this fall. I mentioned the degree will have various options. To kick this, those options need to be offered by other departments of the university. To kick the degree off this fall, we have one option that we can offer, and that's the option of data science, which is actually a very exciting option. As several of you know, I've talked with you out in the reception area, a very hot area in which to have an advanced degree. And some of these blurbs on the side here, just a couple of simple examples. You can go to U.S. News and World Report and find out about how degrees in analytics and so on are one of the best degrees to get. Career possibilities are fantastic, salaries and so on and so forth. I have been a member of some workforce development task forces here in the area. I was a member of a workforce development task force as a member of the Northern Virginia Technology Council, and I was a member of a similar workforce that was sponsored by the prior governor of the Commonwealth, Governor McAuliffe. Both of those task forces were comprised of industry representatives, and at the time I was working in industry, and academic membership such as Virginia Tech. And the message from us industry folk was, we need more people with these skills. We have to have people with these skills given the way business is now being developed and how we're conducting business on behalf of our customers or internally to improve the way we make decisions. So it's a very exciting field to try and get a degree in. So this is the degree that we're looking for applicants this fall, and this is the science option. Let me just point out the courses highlighted in orange are the courses that we have selected to be the data science option. When we develop other options, and there are two underway at the moment, these courses highlighted in orange will be substituted by courses from those fields. So you can imagine an economics option that these orange courses here are replaced by various economics courses. They may be quantitatively oriented or they may be more principles of economics. That's up to the econ department. Similarly, I'm working with a faculty member in biostatistics, and those courses will be filled in biostatistics, so you can imagine a person at NIH or CDC or a pharmaceutical company who wants to get a master's degree in data analysis and applied statistics, but wants that emphasis on biostatistics because that's what's relevant for those jobs. So again, the first option we have this fall is this. So let me give you a tour of the curriculum here. The courses in black are the core curriculum. The ones in orange are the options that we may populate in various ways. So in this data science option, we start off with several courses that are fundamental in terms of statistical analysis. And let me talk a little bit about what is data science anyway. There's all kinds of buzzwords about what is data science. Okay, so there are, one of my favorite definitions of a data scientist is the following. A data scientist is a statistician who knows more about computer science than your average statistician, or a computer scientist who knows more about statistics than your average computer scientist. So the two fields that come together in that definition are statistics and computer science. Whether you come at data science from the statistician's perspective or you come at it from the computer scientist's perspective, they're both using the same algorithms, they're both using high-powered computing techniques, they're both trying to analyze data, they're both trying to visualize data, etc. So we come at that data science degree from the statistician's perspective. We give you a solid grounding in statistical analysis. Why is that important? Because it emphasizes ability to understand whether you have a good model, make an appraisal of it, understand whether it's working, figure out whether an alternative technique might be better for this particular situation. how to select what data to analyze, how to relate that data, importantly, to the leading question is, what is it the question that we're trying to solve here anyway? And we have courses in the curriculum that attack the problem of doing data analysis and data science from those perspectives. So it starts off with an introduction to statistical programming, and there's a second course in advanced statistical programming. The language that we'll use in the curriculum is R. There are other choices. Python is a very popular choice and an important choice. And R is an alternative, and we've selected R as the lingua franca of the program. That's not to say you won't learn a little bit of Python along the way, or you couldn't apply Python to these problems, but the language that will run through the program is the choice that we have made is R. It's a very, very widely used language for data analysis with a huge library of algorithms that are available. So you get a basic, or rather an introductory course in statistical programming and an advanced course. And we'll talk about topics in the advanced course such as computing in the cloud, Spark, Hadoop, things like that. We're not going to teach you how to build a Spark cluster, but we'll teach you how to do parallel computing on a contemporary computing platform, which is a very important skill to have for employers, as I'm finding out in my discussions with them. Statistics and Research 1 and 2 cover some real fundamental techniques of statistical analysis, specifically regression, simple regression and multiple regression, and analysis of variance in mixed models. So you learn some very important basic techniques that are a foundation of all of these other techniques, including the more advanced so-called data science techniques. Effective communications and statistics, you could sort of relabel that as how to be a consultant. Okay, you've done the analysis. Starting off with, by the way, and this is a very important question that I don't emphasize enough, understanding what the question is in the first place. Okay, you're working with your business partner, or your domain expert, or your boss who has laid on you a problem, and you're trying to help solve that problem as part of an interdisciplinary team. So, in the Effective Communications and Statistics course, we teach you how to be part of that interdisciplinary team, and having done the analysis as the expert at doing data analysis, how to communicate your results back. How to visualize those results, how to explain the results of your modeling, how to qualify it, how to tell people how to interpret those results, etc. So that's what that course is about. As you move into the curriculum here, we get into advanced methods of regression, which really delves into how do you evaluate the model. It's one thing to get an Excel spreadsheet, push the button and run a regression analysis, and you don't know, in fact, whether you have a good model or not. All you have is a bunch of t-statistics that tell you this coefficient is significant or it's not. That's not the end of regression analysis by far. Understanding how good the fit is, understanding the relationships between the input variables and whether or not you have too many factors in the model or not enough, or which ones are important, etc. That's what this course is about. We also get into the first, quote, data science courses. Data analysis 1 and 2 take you well beyond regression into some of the things that are part and parcel of what is called the data scientist toolkit. Supervised learning, unsupervised learning, principal components, machine learning, neural networks, deep learning, support vector machines. I know I'm throwing a lot of technical terms at you. Some of you came here to hear whether we're doing things like that. And the answer is yes. That's what part of this program is about. And those two courses in particular take you well into the data science space, well beyond classical statistical techniques, as important as they are. You get into the advanced statistical programming course. I mentioned that a little bit more. By the way, between these two courses, you'll learn how to write a proper program in R. You'll learn how to use that tool. You'll learn how to document your results. You'll learn how to write reports that present your results. You'll learn how to visualize data, present visual presentations of your data, etc. Experimental design for data science. Here's an interesting course. I'll share a little anecdote with you that at least surprised me and kind of caught me off guard, and I think it's a little bit funny if you understand what I'm about to say. So I'm working with some colleagues. We have a curriculum committee, people like Laura, part of the faculty, who are designing this curriculum that I'm presenting this to you. So it's not just me dreaming this up. You have a committee of faculty members at Virginia Tech who are trying to figure out what is the degree we should present to achieve the aims that I've tried to describe to you, career advancement and that sort of professional development. So originally this was a course in experimental design, and I thought to myself, what is a course in experimental design doing in this curriculum? I'm not in agriculture. I'm not doing split plot factors and trying to figure out whether this soil treatment is going to be different than this one, et cetera. And I picked up the phone and I called a buddy of mine who now, he was a professor at Wharton at the University of Pennsylvania, full professor in statistics there. He's now working at Amazon, making, by the way, a lot of money. So I picked up the phone and said, Bob, I said, I got this course in experimental design in this curriculum. What do you think? Does that belong there? He says, man, you got to have a course in experimental design. So it kind of blew me away. And he said, all the time, we are tinkering with our website, doing A/B experiments, trying to figure out what makes the website more sticky. Does changing this keep people on the website longer? Well, that is an experimental design question. You have a control, you have a treatment, or an experimental unit, the change in the website. You're trying to compare them. You have to figure out what data to collect. You have to plan your experiment, and so on and so forth. So these are the principles of experimental design applied to data science questions. Very interesting special topics course. I'm glad I picked up the phone and called my buddy at Amazon. Statistics ultimately has a mathematical foundation. This is a very applied curriculum, but nonetheless, we want to give our students the foundation of understanding how these methods work, why they work, when they work, that sort of thing. And that's what this course is about here. Don't be intimidated by this. This is an important course in terms of giving you a solid foundation, and from, as I said earlier, the statistician's perspective about what data science is about. Lastly, you get the project and report, capstone project if you want to call it that. An applied project, you could work on this solo, you could work on it as part of a team. We'll figure out how to do that with you. You could bring, and we certainly would like to encourage that. It's not on this slide. I got it somewhere else. You're employed by somebody. Maybe that employer is actually subsidizing your education a little bit. Some employers do that. Even if they're not, how can you bring a project into the curriculum? Well, you might bring a project from work. So you work with your employer and say, look, I'm taking this master's degree program. I can apply myself to solving an important business problem for you all. How about that be my project? And you bring that project into the curriculum, and now you're delivering value back to your employer, and it fits in with your plans for career advancement. Because when you get the degree and go back, you've helped solve an important business problem. So that's what the project and report is. Have a problem from your employer or one that you want to work on somehow, we'll find a problem or a project to work on. And these projects mentored by a faculty member. You'll not be on your own. You'll have somebody working with you, perhaps myself, perhaps Laura, perhaps another faculty member will mentor you, will bring you along, give you advice about the project. What should you be trying? What should you be thinking about? How do you get to the end point, etc. So, preferred background. We're going to evaluate this on a case-by-case basis. As we're experiencing people coming into the program, they have a very diverse variety of backgrounds. They are not necessarily math majors, nor are we necessarily looking for math majors, although they're very welcome to come into the program. But I've got people calling me from social sciences, people who are doing analysis on the job using Tableau or Excel or something, and they see the value of the skills and the possibility of career advancement. They don't necessarily have a strong math or statistics background, but they're doing it on a daily basis, and now they want to know, how do I really do this stuff? So in terms of the background, we're going to evaluate everyone on a case-by-case basis and hopefully offer sound advice to you about, do you have the background necessary to come into the program? If you have this kind of background or the equivalent experience, you are a candidate for the program. And there's no getting around it, and it's not intended to be apology. There is a mathematical foundation and a programming foundation to a degree like this. So you have to have some fluency in those areas. And if you had a year of calculus or an introductory statistics course, or maybe you took a couple of computer science programming courses, you probably have the skills to come into the program. We'll talk to you about that and figure out whether you're a fit. And I think I have covered all of the points on this slide. I'm looking for questions, and this is a good time now that I've taken you through a high-level tour of the degree. Anybody have a question? Please.
Great question.
Yeah.
Was about the computing or advanced statistical programming. You mentioned that we'd be going over Spark and focusing more on doing the parallel programming, the analysis. So do you go over the big libraries like MLlib and Spark for any of the courses?
Yeah, we'll be doing that in the Advanced Statistical Programming course. So I mentioned R is the lingua franca. There are packages in R for doing parallel computing, accessing a Spark cluster, accessing a relational database, etc. You'll see those things being taught in that course. So you will know how to use R as an analysis tool to do computing on that kind of platform. Does that answer your question?
Yes, R would be the rapid doing stuff like Sparkly R or
Yeah. That's what I'm talking about. Yep. Yes, sir.
Will you offer any of these courses to people not enrolling into the program? Just people who may be interested in individual courses?
There is a program called I've forgotten the exact name, but
Commonwealth Campus.
Commonwealth Campus. Thank you, Sherry. See, I told you she's a big help. There is the possibility of being able to take courses without pursuing the degree program. And we'll handle that again on a individual basis. What is it you're interested in doing, etc. There are some requirements that I can't recite off the top of my head for being a Commonwealth University student, but there is a path to be able to take some courses. It's a limited number of credits you can take in that, but you can do that.
We also offer a certificate program.
Yeah, I should mention that.
We should really talk about that.
Yeah, thank you, Sherry. The first 2 semesters of this, these 4 courses, you can enter the program with the intention of taking only those 4 courses, and you will get a certificate. Or you may find that having entered the program with the intention of getting a degree, maybe it's not your bag. You've decided that's not the pathway for me. You can exit the program at the end of the 2 semesters, and you will get a credential. You'll get a certificate from Virginia Tech in data analysis and applied statistics. Thank you, Sherry. Let me talk a little bit more. What I wanted to say here was, you can enter any semester. So if you entered this fall, you'd be following this progression. If you entered this spring, the next spring, you'd be following this progression. So you can enter the program at any point. Here's where you start. So year 1 begins the semester you enter the program. Any other questions at this point, please? Yes.
Are these all new CLEP courses, or have some of these been taught before?
Oh, they've all been taught before. With two exceptions. The Intro to Statistical Programming has been taught before, but we are reorganizing the coursework, the syllabus, if you will, specifically for this program. And in fact, it'll go back into the regular programs at the Blacksburg campus. So we're tweaking what was previously offered as this introductory course because we want more content in that course. It's sometimes been offered as a 1-credit course. All of these are 3-credit courses. The other course that's really new is the Advanced Statistical Programming. And that is a course we are creating. Laura and I are, in fact, I should mention, Laura will be teaching this Intro to Statistical Program. So she is the instructor for that. And so she's working with one of the other professors who is assigned to develop the syllabus and some of the course materials. And I am involved in that as well to make sure that course achieves the objectives that we are trying to achieve for the program. Going back to your question, all of the other courses that you see here are in the catalog, and they have been taught for years, if you will. Yeah, thank you. We have a course in experimental design. In fact, we have several courses in experimental design. This one, we're tailoring one of the courses to be more oriented to data science. So it's not exactly a new course, but it is a tweak of an existing course. Yeah. Yeah.
Would visualization be part of the course?
Pardon?
Data visualization?
Data visualization is carried, we introduce the R packages that are associated with that in the statistical programming course. Is there a particular package, I'll throw out the words, they may not mean anything to you, called ggplot, that is a fantastic package for designing statistical graphical presentations. You will learn how to use that package, and then you will use those skills throughout this course. So in effective communications in statistics, one of the most effective ways to communicate a statistical result is in a picture. And in fact, in my experience, it's sometimes the only way to really get across the point is through a graphic. And so you will learn the tool, and then you will apply your skills using that tool throughout the curriculum. And in some homework assignments, you'll be specifically asked, okay, I want to see a visual result here, not just a table of F statistics or T statistics or what have you. More questions, please? Yeah.
Any Bayesian components?
Yeah, there's Bayesian stuff that runs through several of the courses here. There's not a specific course in Bayesian analysis. You'll get some of that in here, but you'll also see it in other places here, in the advanced courses in particular, because it's a contemporary way of looking at how to do an analysis and so on and so forth. So there's Bayesian themes that run throughout the courses. Yes, sir.
More of a philosophy of what you need to get the job done than specific the theory behind Bayesian.
Right.
So as you progress up in the advanced level, you're going to be getting more and more Bayesian techniques.
Yep.
So since I believe you mentioned data analysis 1 and 2 have been taught before, and you said you went over a lot of supervised and unsupervised learning, I guess my question there was, you'd also mentioned that you learn to write a proper R program. So do you emphasize a lot of students whiteboarding these algorithms from scratch before using the libraries, or is it mostly just emphasis on this is the math like on a slide, and then do more emphasis on the libraries?
I'm not sure I understood the question.
So would you, for example, write something like SVM or a random forest from scratch first and then use the libraries, or is it more emphasis on just doing the libraries in R? No, well, Laura may have a different opinion, so I'll ask her to speak up here in a minute. But we're having a conversation about this. I don't anticipate we're teaching you how to write a decision tree algorithm. Rather, using the library and figuring out whether decision trees are the way to approach this problem, and if they are, how to evaluate the results of that kind of modeling, or pick any other technique that you want. So more emphasis on the libraries and understanding whether you have chosen the right tool to solve this particular problem.
Yeah, so I agree, not rewriting methods from scratch.
Right.
We also discussed these classes aren't just going to be us doing a list of libraries.
No.
Because that would be really boring, and you can read it on the internet. So it's more about what the
Yep. Another question? Yes.
So I'm a recent graduate of SPIA with the Center of Public Administration and Policy. All this would have been really useful to help me with my dissertation.
It's not too late.
But, however, yeah, are you doing outreach to the other programs up here in the Northern Virginia area? Because I think that, all these things are something that are useful for interdisciplinary
Yeah.
work and
Outreach is an ongoing task for me, for sure. And so, for example, Laura, who works in the Hume Center, she and I are having a dialogue about, well, maybe there's a cyber option. I talked about options earlier. So working together, she has some thoughts concerning that, et cetera. So, yeah, and that's an ongoing task. And where I hope that will head is back to the idea of options. Those 4 courses that are highlighted in orange, they'll be filled in by others. So it might be the SPIA program saying, well, I'd like to populate this with, I'm sorry, I don't really know enough about the program, but there might be courses in the discipline of SPIA, whatever that may be, and then some particular quantitative courses that are especially helpful when you're doing that kind of work. And that would be sort of the general model for developing these options. So, Laura, why don't you talk about that in terms of, how you might introduce something in cyber here in terms of what kinds of courses would be involved in that.
So we actually have a cybersecurity master's level certificate now. That's 4 courses. So that would be a natural certificate program that you would plug in to this, which basically has like network fundamentals. There's different options within that certificate program that people can exercise. So plugging in kind of an existing certificate is one path. Or like with SPIA, you might want to do like a customized new track with SPIA collaboratively where it's like just data-driven decision making or something like that in the policy and international affairs realm. So that would be a very different way of plugging into those tracks. But yeah, you pretty much covered it.
So why don't I move on to, we've got 2 more slides, it won't take too long. This has been great. I mean, I don't want to stop answering questions, but all right. So I mentioned this a little bit. So you're working professionals, 2 courses per semester. 1 course will be a live lecture, the other asynchronous streaming video, by which I mean the course will have been pre-recorded by a faculty member, and modules will be released, and you can stream those video modules according to whatever suits your schedule. There'll be a faculty member who backs up that course with office hours, etc. So you're not just on your own, but you're streaming the video according to your schedule, whenever that works for you, weekends or your day off or whatever it is may be. The other course, live lecture, we have a very nice facility in Falls Church, about 15 minutes up the road, just off of 66. It adjoins the, what? Oh, sorry. We have a facility at Falls Church. It's adjacent to the West Falls Church metro station. That's where the live lecture courses will be taught. Laura's teaching the statistical computing course. That's a live lecture. Research and Statistics 1 is going to be the pre-recorded course. There'll be a faculty member associated with that. I mentioned this already. Use a work-related project to fulfill your project requirement. Did you have a question, sir? Oh. And then lastly, basic admission requirements. Bachelor's degree from somewhere. Cumulative GPA for your last 2 years of study. You take the GRE general test. Quantitative, there's 3 parts to that test. There's analytical reasoning, analytical reasoning, verbal writing, one or the other. I've gotten a little confused. And quantitative reasoning. You need a threshold of, on the quantitative reasoning portion of the exam. This is a way of assessing your mathematical abilities to take on the courses. You need 3 letters of recommendation. If you happen to be a non-U.S. resident, you need to take the TOEFL exam, test of English as a foreign language. And then the way it works is you submit your application. The applications are referred to me and a faculty committee, such as Laura. We review your application. If it's appropriate, we make a recommendation to the graduate school to admit you into the program. The graduate school is the ultimate threshold to pass. It's only in exceptional circumstances where they wouldn't take our recommendation. And assuming that they pass on the recommendation, you're then admitted into the program. And that's the process. We are, as I mentioned, accepting applications for this fall. If you were interested in doing so, and I hope some of you are, you should get about making your application. Classes start, I think it's August 23rd or 26th, something like that. So you need to get your application in so we can go through the review process and make the recommendation to the graduate school. That's the presentation. I'd be happy to answer more questions. Or we can do it out there with a glass of wine. Any burning questions before we break up? Yes, Sherry.
So everybody knows, what is the date for, like, what's the last date for accepting applications?
Early in August, and I'm going to try and take it to the very last minute, so I'm not going to quote a specific date. You get me your application, I'll make sure we get it reviewed. And I encourage you to do that. Well, thank you all very much for coming, and thanks for all the great questions. I'll be out there for a while sipping on a glass of wine and be happy to answer more questions. Thank you so much.